Hi, Nate Rubin here with Photorhythm. Today I'd like to show you an app that we've developed to monitor heart rate using a camera. I have the Nexus 9 tablet that I'll be demonstrating this on. We did write an Android app, so this can run on a variety of hardware. This is the device we have been developing it on. So, as I open up the app, I'm presented here with a viewfinder, and this is an internal app that we use to validate our algorithms and how they run in the wild. So I want to show you some of the settings and controls that we have available here. If I swipe from the left, I have quite a few options available to me. I have the algorithm settings, which I'll come back to in a minute, and here at the bottom I have camera settings. And I'm able to toggle between manual or auto mode. This is the auto recording mode. I think I'm going to stick here in manual. I can switch whether I want front or back camera, resolution, frame rate. I can even change things like the ISO on the fly or the exposure time and a couple other settings. I think we're pretty happy with what we have there. Let's take a look at our acquisition menu. Now this pane deals with how we actually compute the heart rate, or how we get the pixels to compute the heart rate. So in every frame of a picture, I want to find the pixels that are associated with the skin, and I'm going to add all those together and find the average red, green, and blue, which I'm going to, for every frame, feed those into a time series signal, and then I'm going to feed that into my algorithm. So this just shows that we have a couple different ways in which we can get those time series signals. One is to just place a region of interest on my face, a relative box to a face detector that I'm using, and again inside this green box here are all the pixels that I'm going to add up and get the average colors for. Let's take a look at a skin detector that we've developed, and what this does is it classifies all of the pixels within the face box as either being skin or non-skin. And as you can tell, it doesn't get all of my skin, but it does get the most important parts. It does have part of my forehead, a little bit of my nose, my cheek, and those are good areas to look for heart rate. So I'm pretty happy with that. Let's take a look now back over here at the algorithm settings. Here we have a couple of different algorithms which we can use. I'll just point us to this first one for demonstration. At the bottom here I have a pane that will show me my heart rate and the current frame rate of the camera. And if I swipe up, I get live data feed of the signals that my algorithm is consuming. So this first one is the actual raw data, and what I'm plotting here is the average green color of all the pixels on my face. And as you can see, there's definitely parts that look heart rate to like, and there's parts that change quite a bit due to just my head moving around or other lighting changes, cars driving outside. Anything that changes the light in the scene ever so subtly will change what the signal looks like. So I go ahead and bandpass filter it, compute an autocorrelation, and here's my power spectral density. And as you can tell, it's all over the map. I don't believe it's accurate, and that's again all due to the motion artifacts introduced by me just moving around. So even my hand shaking a little bit. So let's move to the second algorithm. This one, it appears a lot like the first. This is the same data we were looking at before, just the average green channel. But then I actually apply a detrending signal to it. And if you look closely, there is a small green signal that appears to be following the average green signal. And when I remove that, I get a much cleaner looking heartbeat signal. This isn't the true heartbeat signal, but it's what we're going to derive the heart rate from. So again, I filter that, and now I can see and I take the FFT and see the spectral information from this way of monitoring. So over here I have a pulse oximeter that I've just placed on my finger. I'm going to try and get both of these in the scene. I hope you can see that. And now I'm showing my heart rate. It's pretty high, probably because I'm making this video. And that's actually what the there's a pretty high agreement between the pulse oximeter and the application. About 84 beats per minute, mid 80s, start to drop down, lower 80s. And you can see other spectral information leaking in that aren't due to heart rate. Again, this is just things due to motion. This is a very tricky problem to solve, and this is one of the ways in which we solve it. I've only demonstrated 2 of the algorithms in which we've already coded up in this Android app that we use. There's going to be more to come. That's probably all I have to show you today. This is an app that we anticipate to place on the Google Play Store. It's not up there yet, but you feel free to check out our website. There's going to be a link in the description below, also our LinkedIn page, and we'll let you know when that comes out. Also, feel free to leave a comment, ask any questions. You can also go to our website and ask us questions directly. They'll show up in our inbox. And we're happy to answer any questions that you have about this technology. Thanks for watching.